Hi, welcome back. Now we'll be discussing about work. So what is work? Work is generally a transfer of energy, and this transfer of energy, right, can be from one object to another object or from one energy to another energy. So work done can also be calculated, and the definition of work done is that it is the force applied on the object that caused the object to travel a distance in the same direction of the force. In other words, work done equals to force times distance, where work done is in joules, force is in newtons, and distance is in meters. Okay, another SI unit for work done would be Newton meter, but I would strongly suggest you to use the word joules. Now, in the event that the distance being moved is not in the same direction as the force, for example, when you push the box in this direction, it actually moves upwards. This will show that the distance from here didn't change at all. It still remains in the same distance. So this would mean that distance would be 0. So even though you use 100 newtons of force or more, or any amount of force, any number times 0 will have 0 work done. Okay? So it is very important that the force must be aligned with the distance actually moved, or you can say like more or less parallel to one another. So 1 joule is the work done by a force of 1 newton to move an object by 1 meter. Please remember this formula, as this is very important for exam. Now let's look at some questions that can be asked in terms of this particular area. So a man pushes a trolley with a force of 10 newton. So you have one man pushing something, a trolley maybe, with a force of 10 newton. So this one 10 newton. The trolley travels for a distance of 1.5 meter to a stop. So calculate the work done. So work done equals to force times distance traveled in line in the same direction of the force. So it will just be 10 multiplied by 1.5, because distance is already in meter. You will get 15 joules. Okay. A boy weighing 600 newton is lifted to a vertical height of 4 meter. So what you do is, again, do take note that the weight of the box is mainly in terms of force. You can recognize it by the SI unit. So work done is just 600 multiplied by 4, 2400 joules. Now, a mass of 0.5 kg is pushed along a slope from P to Q by a force of 12 newton, as shown in the diagram. Calculate the work done to move from P to Q. So this one, it will just be again 12 times 8, 96 joules. Now, what happens if the question wants to trick you and would draw another height here? Let's say this one is 10 meter. Please do not use this height at all. Why? Because which is the same direction. The force is moving in this direction here. The length is also here. Yes, in a sense that you could say that the box is also moving upwards, but in terms of accuracy, it is really, as long as the force direction is parallel to the direction of the object being moved, that would be the value that you want to use for your calculation. Okay. So what is the distance traveled by the trolley if the work done by the man is 360 joules? So this will be just the opposite way, where work done equals to force times distance. So distance will be work done divided by force, and you'll get the answer. So there are other trick scenarios, like for example, let's say you're given a wall and a person is pushing against the wall. The wall is not moving. You push maybe 1000 newton. the work done will be equals to 0. Why would it be 0 joules? It's because the distance of the wall didn't move, the object never moved. So 1000 multiplied by 0, you will get 0 joules, so no work done. Another example is, let's say you walk up the stairs. Okay, you are walking from here up to here, and you realize that this is 10 meter. What is the work done from not walking up the stairs but carrying maybe a book or an object upwards? What you need to do is to really calculate the distance, the distance from here until here, and not using a 10 meter, unless you say that you actually put a lever and you actually lift the box upwards that is the same direction, then you can calculate it, where the force, the weight, would generally be the weight of the box. Okay, so that's all I have for work done. You can practice more questions, and then from there we'll see how. Okay, thank you.